Here is all choose from chapter 3, question number 1. On this part we have these numbers given on this table, and we have 9 students as population. So determine the population mean. For part A, we have to enter all these numbers into TI-84. So use stat, edit, enter, and enter these numbers into one of the columns. We have 6 columns, and I entered these numbers in L1. So these are the numbers that we have here. And the next step is stat. Instead of edit, highlight calc, use number 1, varstat. I entered these numbers into L1, so here on this part, on the first row for list, I should have same column, which was L1. I will not enter anything for second row, frequency list, so nothing on that part. Enter, enter, enter. So here is our sample mean. It's asking to run to 1 decimal place, and the answer is 73.6. Part B, determine sample mean. Here, our sample size is 3. We have sample 1 and sample 2. So each one of these, the sample size is 3, and we have Jeff, Kevin, Klaus. So finding the numbers that we have for each one. For Jeff, we have 88. For Kevin is 85. And for Klaus is 88. Again, we have to enter these numbers into TI-84, and same steps using stat, calc, number 1, varstat. Here again, it's asking to run to 1 decimal place, and the answer is 87. For sample 2, we have Crystal, Katie, Kevin. So here, Crystal is 70. Katie is 63. And Kevin is 85. Again, we have to enter these numbers into one of the columns. We have 3 numbers, and then use stat, calc, number 1, varstat, same as what I did for part A, to find the answer for this one. Again, it's asking to run to 1 decimal place, and the answer is 72.7. Now here, part C, determine if the means of samples 1 and 2 overestimate, underestimate, or are equal to population mean. So the first one, mean of sample 1, it's 87, and population mean was 73.6. This 87 is greater than 73.6. That means this one is overestimate. The mean pulse rate of sample 2 mean is 72.7, and here population mean is 73.6. This is less than 73.6, so this number 72.7 is less than what we have for population mean. That means for this part we have underestimate. Now here on this part we have these 2 data sets, bond mutual fund and stock mutual funds. Part A, it's asking to find mean and standard deviation So for each one of these data sets, we have 8 randomly sampled bond mutual funds, and the other one is 8 randomly sampled stock mutual funds. So we have to enter these numbers into TI-84 to be able to find mean and standard deviation. We can find by hand, but finding standard deviation takes time, so it's better to use TI-84 here on the spot. So we have to use stat edit to enter these numbers. I entered one mutual fund into L2 and stock mutual fund here L3. So first, working on bond mutual funds, use stat calc number 1 var stat, enter. Now for list we should have L2 because I entered these numbers into L2 for bond mutual funds. So this one L2, enter, enter, enter. It doesn't matter what column you use, but the point is that the column that you use to enter these numbers, you should have same column here on the spot for list. Enter, enter. So this was our answer, 2.275. And here it's asking to run to 3 decimal place. I'm not running. This is exactly equal to this number. And our standard deviation here, it says 8 randomly sampled. So this one is sample. This is not population. Because of that, our standard deviation is sample standard deviation. It's not population standard deviation. So the answer is 0.669 running to 3 decimal place. So here mean is 2.275, and here we have 0.669. And next part is asking for stock mutual funds. So do same. Enter these numbers. I enter these numbers into L3, stock mutual funds. And then again, stat, calc, number 1 var stat, enter. Here for list, we should have L3, so it's second, 3 to enter L3. Enter, enter. Here's our answer for sample mean running to 3 decimal place at 7.913, and sample standard deviation is 0.903. But here again, it's asking to run to 3 decimal place. The next part, based on only standard deviation, which data set has more separate, we have to compare these two numbers because it's asking for standard deviation. The one that we had for bond mutual funds was this one. And for stock mutual funds, our standard deviation was 0.903. So what we have for stock mutual funds, that is greater than what we have for bond mutual funds because of having this greater than bond mutual funds. And here it's asking based on only standard deviation, which one have more separate. This is larger number, so that is the answer for more separate. If it was less separate, the answer will be bond mutual fund. But here it's asking for more separate, so the larger number, that is the answer for this part. Stock, mutual funds. Part C, what proportion of the bond mutual funds are within one standard deviation of the mean? So within one standard deviation, using empirical rule, I only have one standard deviation, so I will find the answers for within one. So here we have x bar. On right side we have x bar plus 1 times standard deviation. On left side we have x bar minus 1 times standard deviation. And our x bar for bond mutual funds was 2.275 plus our standard deviation was 0.669. So here we have 2.944. And here on left side, we have to subtract. So x bar minus standard deviation, so we have 1.606. So our interval is 1.606, comma 2.944. Now based on what we have here on this part, and the numbers that we have for bond mutual funds, we have to see what numbers are within one standard deviation. So 3.1 is not inside, it's not between these numbers, it's outside. 1.8 is inside, 2.3 is inside, 1.5 is outside, 1.7 is inside, 3.3 is greater than 2.944, so it's outside, 2.6 is inside, 1.9 is inside. So we have, out of 8, we have 5 numbers that are inside and are within one standard deviation. Now it's asking for proportion. So out of 8 numbers that we have for bond mutual funds, 5 numbers are within one standard deviation. So we have 5 divided by 8. The answer is 0.625. So this is the final answer. Again, same thing for next part. What proportion of the stock mutual funds are within one standard deviation? So this part is same, and we have to find, because of asking for within one standard deviation, again we have to find x bar minus 1 times standard deviation and x bar plus 1 times standard deviation. So we have 7.913 was over x bar minus standard deviation was 0.903. And here on the right side we have to add. So what we have here is 7.01, comma 8.816. So this is our interval for this part. And now we have to see what numbers are within one standard deviation from stock mutual funds. So 9.3 is greater than 8.816, so that is outside. 9 is outside, 8.3 is inside, 8 is inside, 7.5 is inside, 7.3 is inside, 7.1 is inside, but 6.8 is less than 7.01, so that is outside. So again, out of 8 numbers that we have here, 5 numbers are within one standard deviation. Here on this part again, we have 5 divided by 8, and that is 0.625. And this is the final answer for this part. Now this part is asking to find coefficient of variation. We didn't have this part in lecture, but the formula is given. So we only need to use formula to find the answer for coefficient of variation. So the purpose is to know what is standard deviation and mean, and then divide to find the answer. So the first part is for bond mutual funds. And here we have 0.669 divided by our x bar was 2.275. It's asking to run to 3 decimal place. It's 0.294. So that is the answer for this one. And the next one is for stock mutual funds. So it's 0.903 was our standard deviation divided by our x bar was 7.913, running at 0.114. Now it's asking which one have more separate, so based on coefficient of variation, based on these two numbers. Which one have more separate, meaning that which one is greater than the other one. So the one that we have for bond mutual funds, it's 0.294, and that is greater than what we have for stock mutual funds, 0.114. So the answer for this part is bond mutual funds. Here again we have the data set given, and it's asking for mean and standard deviation. So this part is same as what we did here on this page. Again, we have to enter these numbers into TI-84 in one of the columns, and then find the answer for mean and standard deviation. So start edit. I entered numbers for inches in L4 and for centimeters in L5. Now stat, calc, number 1 var stat. Here I should use L4, so second 4, because I entered numbers into L4. Then enter. The first data set that we did on top the output was sample, and assume that this one is same thing, sample instead of population. So the answer for export is 70.5, and our sample standard deviation running to 3 decimal places 2.330. So 70.5. I'm going to write 00 here to have 3 decimal places. It doesn't matter how you write 70.5, it's same as 70.500. In here 2.330. For the other one, so I enter these numbers into L5. Now stat calc number 1 var stat. I should have L5. So second 5. Then enter. Our export is 179.07 and sample standard deviation is 5.918 run into 3 decimal place. So based on standard deviation, which one has more separate? So standard deviation, compare these two numbers. The one that we have for centimeters is 5.918, and that is greater than what we have for inches. And here again it's asking for which one has more. Again, it's asking for CV. So our standard deviation was this one, and divided by sample mean, it's 0.033. And here same thing. Divide, round. Next part, what is true of the coefficient of variation? So after finding the answer for both of these, here we have same answer. So based on what is given, this is what we have. Coefficient of variation is unchanged. So it is part B. The answer is B. Next one. We have this data set given. We have all these numbers. So in this part we have negative numbers. To enter negative numbers, you have to use this one. This one in parentheses, that is negative. Do not use this. This is subtraction. So it's not that one. That is subtraction. So division, multiplication, subtraction, addition. But negative, it's this in parentheses. So use that to enter negative numbers into TI-84. I entered all these numbers in L6. Now stat calc. Number 1 var stat, we have same steps, same as what we did to find mean and standard deviation. So for this part again, stat calc number 1 var stat, enter, and I used L6, so it's second 6. For this part, our list, enter. This is what we have, but we have to scroll down to see all the numbers that we have for quartiles. So use these to move to left, right, up, and down. Here I have to use this one to scroll down. And here is what I have. For Q1 it's negative 0.02, median or Q2 is 0.03, and Q3 is 0.095. Here it's asking for decimal places. I have negative 0.02 or negative 0.0200. Here is 0.03 or 0.0300 to have for decimal place. And this one 0.095 or 0.0950. And then to find outliers, we have to find lower fence, upper fence. So first find inner quartile range, which is Q3 minus Q1. So Q3 is 0.095 minus Q1. That is 0.115. And then finding lower fence. This is, for lower fence, we have to start with Q1 and then subtract. Subtract 1.5 times inner quartile range. Q1 is negative 0.02 minus 1.5 times 0.115. Here is negative 0.1925. And now upper fence, for upper fence, we have to start with Q3 and then add 1.5 times inner quartile range. So Q3 is 0.095. Here inner quartile range 0.115. So we have 0.2675. So what we have for lower fence, upper fence. Lower fence negative 0.1925 and upper fence 0.2675. To find outliers, we have to see if do we have from this data set, do we have any number that is less than lower fence or greater than upper fence? The only number that we have is 0.48, that is greater than 0.2675. So our outlier. So we have outliers, and that is 0.48. Next one, here it's asking for this shape of distribution. Here, this box, this one is longer than what we have here on left. And this whisker on right side, this part is longer than what we have on left side. This means we have skewed right. Then it's asking for find number summary. Find number summary for minimum number that we have here is 0. Then we have that part is Q1. The number that we have here is 1. Median or Q2. This is 3. Q3. Here we have 7. And our max, here on this part we have 17.